Hello students, welcome to today's session. Today I'm going to be taking you an introduction to dimensionality reduction for machine learning, and I am Peter Chimaobi. We are going to be taking these under the following subtopics: the definition of dimensionality reduction, importance of dimensionality reduction, and the method used for dimensionality reduction. First, we take the definition. As the name dimensionality reduction entails, it's basically the reducing of the dimension of a data set. Or you can also define it as removing of random noise, random variables from a data set and replacing it with principal component variables. So the importance of dimensionality reduction is, as earlier stated, removal of noise. Most data contains noise, and it's important to remove this noise so that it doesn't clog up the clean and existing data. It also reduces computation time, such that when you remove noise from the data, it becomes the time taken to compute it and plug it into machine learning models and analytical models becomes quicker. And it also reduces computational storage, such that when the noise has been reduced and discarded, you can easily store your data the data. So, if you have any other importance to add from the definition that we have given, you can feel free to come up with one. From the definition and the importance I've given, you can feel free to add yours. And I want to speak briefly on the few disadvantages. Number one disadvantage is that data will always be lost. Once we are talking of dimensionality reduction, data will be lost because we are reducing the dimension of this data. So the onus is on us to make sure that the data that is being lost is data that we are not going to be needing. Yes. Another thing is, there is no fixed amount of principal components. So you cannot just come into and say, look, I want to select 5 or 10 principal components from so and so data. No. This data can contain 10 principal variables, it can contain 20, the next data can contain 50. So you keep on trying till you reach an optimal number. Then you select that. So we are going to move on to methods used for dimensionality reduction. We have two major methods: feature selection method and the dimensionality reduction method. Feature selection, as it entails, means the selecting of features and storing it in a subset. Selected features are selected based on the following criteria: the missing value ratio, the low variance filter method, the high correlation filter method, which both falls under the filter method, the forward feature selection, and the backward feature extraction method. And the other method is the dimensionality reduction. This method basically runs on linear correlation. So we have projection based, which has isomap, TSNE, and the UMAP method under it. And then we have the components or factor based method, which has the factor analysis, the principal component analysis, and the independent component analysis method. So we are going to be looking in-depthly at one of the very important methods, which is the principal components method. Previously we said that it runs on the linear correlation. It runs on linear correlation basically. So it involves moving, as the graph entails, it involves moving data from a higher dimension into a lower dimension. But the thing is, it's done using on the linear correlation platform. The principle it works on is linear correlation. But the problem with this principle is that linear correlation, not all data is related linearly. Some data are not linear. So those non-linear relationships are lost in this process. So you have to take that in mind, that this is one of the few things that run on the background when you are running your PCA method. So you can read more on it, on the method. So next week we are going to continue from where we stopped. Thank you very much. See you all later.